Hello, my name is Juraj Siska and I co-chair Apex 0415 working group. Last year, we delivered an HDR update to the technical specification. This new and exciting update brings promise of higher quality content that makes the viewing experience that much better. In my presentation today, I will discuss options of reducing storage requirements via the use of advanced encoding algorithms. I will also try to answer a question that some of you might have, whether it's possible to distribute all of your in-flight entertainment content using a single video file format. In the case of HDR, the content file sizes are bigger. As a matter of fact, the content sizes of the coveted 4K content are larger than traditional HD content. On top of this, we have a younger audience seeking non-traditional content, bringing more demands for storage space and network bandwidth utilization. Therefore, we are looking at ways to compress the files using advanced encoding algorithms. At this stage of the spec, we are looking at HEVC, VP9, and AV1. My colleagues Philip Watson and Andy Rosen will discuss the benefits of using two encoding algorithms, VP9 and AV1, in aviation. My presentation will focus on how feasible it is to use a single compressed file by airlines' various distribution methods. I will focus mainly on the more complex case, delivery of IFE content to personal devices or pets. Delivery to seatback will have only a cursory preview, as from the encoding perspective, it is a subset of PET's distribution model. This slide talks about various use cases of content delivery on PETs. In particular, laptop delivery to modern browsers like Chrome, IE, Edge, and Safari. In-browser delivery on mobile devices is focused on Safari and Chrome, leaving some popular but not standard-based browsers out. For example, Samsung native browser is not part of its consideration, neither is Firefox or other less frequently used browsers. In-application delivery streaming on Android and iOS is part of this analysis. This use case is directly linked to the seatback use case, as many airlines are using native applications to play content on tablet-like devices. These are likely to be Android-based, and therefore my discussion about mobile apps on Android operating system should be relevant. Unfortunately, Linux or other displays based on other OSs are removed from these considerations. Viewers can contact me or Apex if they would like to learn more about support of their particular configuration. The title of this slide could very well be desktop, but there is not many, if any, passengers bringing desktop computers on their flights. Laptops normally range from Windows to Mac, with some exceptional cases running the Linux operating system. This table shows the best support for VP9 type of content on all Chromium-based browsers and Safari. For those that might need to be refreshed on Chromium-based browsers, these are Chrome, Firefox, and recent versions of Microsoft Edge. Safari started supporting VP9 in the latest version of Apple's operating system, Big Sur. Considering that IE and pre-Chromium Edge are fairly marginal, VP9 is the most represented in-browser codec on laptops. While Google has done well in supporting AV1, and Apple's support of HEVC has been well built into Safari, there is virtually no overlap between these two platforms. Therefore, the goal of playing the same encoded content on as many laptop desktop browsers as possible can be only accomplished with VP9 content. The situation in mobile market is similar. Chrome supports VP9 and AV1, and Safari supports HEVC. Therefore, to be able to encode higher compression video and audio files, implementers will have to use two different streams or throw themselves back to H.264 content, which is universally supported. The support of advanced encoding algorithms is much better via native applications. This is enabled either through hardware accelerations, for example HEVC on iOS, or in software, assuming the device has enough processing capabilities. Here we have support from both AV1 and HEVC algorithms on Android and iOS. VP9 is also supported on iOS. From our last Apex update, version 3, and subsequent FTE presentations, we concluded convergence of DRM technologies to CBCS content. After Google Widewine embraced CBCS encryption, it was finally possible to create one video file that can be shared between Android, iOS, and iPad operating systems, as well as the majority of laptop browsers. This was a very encouraging sign from industry giants like Apple, Google, and Microsoft. The situation is more complicated when we look beyond H.264 content. While the CTR encryption is supported by all in-scope encoding algorithms, CBCS encryption has support from only AV1 and HEVC. VP9 is unfortunately left out. CBCS encryption that was pioneered by Apple will be well supported on HEVC. Some industry experts speculate that Apple might be moving towards AV1 based on their membership in Alliance for Open Media. If Apple announces in one of their upcoming shows that they will support AV1, the quest for single media file might be answered by using CBCS encryption and AV1 encoding. If Apple turns out to support AV1 in one of their upcoming public announcements, the solution for single DRM encrypted file might be AV1 with CBCS encryption. Apple's AV1 support on Safari on laptops and mobile systems like iOS and iPad are the only missing link, albeit significant one, considering how popular Apple devices are. Until then, the market will likely stay divided, and IFE vendors and airlines will have to balance several factors in order to get the most out of their storage and network bandwidth when serving high-quality content. A workable approach might be looking at the content quality and resolution and assess which content requires the highest compression rates. For example, if an airline decides to use 4K or HDR formats for first-class cabin for seatback displays only, they have a choice of using either AV1 with CBCS encryption or VP9 with CTR. Similarly, if the majority of user devices have relatively recent Android-based mobile phones and tablets, they can use CBCS encryption with AV1. Based on today's state of technology, the safest solution for delivering content to Apple devices is using HEVC content with CBCS encryption. Let's pay attention to the news coming from Apple this year, especially around the Worldwide Development Conference scheduled for the beginning of next month. I'd like to bring to your attention the work of my colleagues and co-chairs. Watch Phil Watson's presentation on IFE and potential benefits of new codecs. Watch Andy Rosen's presentation on cost versus value. Do Hollywood's codecs fly? This concludes my presentation on reducing storage requirements using enhanced encoding algorithms. If you have any questions, feel free to contact me either via email, phone, or via our website. Thank you.